Okay everyone, let us now proceed to Module 3, all about radicals and rational exponents. So let's start with lesson 3.1, radicals and their properties. Okay, so if we take two real numbers a and b, and n is greater than or equal to 2, then if a is equal to b raised to n, then b is the nth root of a. Okay, so let's have some examples here. Let's say you have your 81 is equal to 3 raised to the 4, right? Okay, so if that's the case, then negative 3 is the fourth root. As you can see here, this is the fourth root of 81. Okay, let's have another example. 32 is equal to 2 raised to 5. So therefore, 2 is the fifth root of 32. Okay, so we also have special names for specific values of n. Let's say, for example, we have n is equal to 2. That is known as, this is popularly known as the square root. And n is equal to 3 is popularly known as the cube root. Okay, so if we have 25, as an example, 25 is equal to 5 squared, then we say that 5 is the square root of 25. Okay, so n is equal to 2. Then if we have, say for example, 27 is equal to 3 cubed, then 3 is the cube root of 27. Okay, so now let's discuss the principal square root. So the positive numbers, this is the positive number square root unless otherwise stated. Okay, so and it is designated by this radical symbol. So a here is the radicand, and this symbol right here is the radical symbol, and n here is the index. Okay, so there is a common misconception when getting the principal square root. Let's say, for example, we have the square root of 4. It is commonly known to be the result is commonly known to be positive negative 2. So this is wrong. Okay, so this is wrong. So we are so when we say square root of 4, we are referring to the positive result of the square root of 4, because it was not stated that you're going to include the negative sign. So there is a difference. So this will be negative if we have negative square root of 4. So we perform this first. So we get negative 2. Okay? So there is the difference between this one and, let's say for example, x squared minus 4 is equal to 0. Okay, so if you were asked to find x, let's say for example, so if we manipulate this, you will get x squared is equal to 4, right? And then x is equal to, then we say that x is therefore equal to positive negative square root of 4, right? So this is positive negative. So this is positive negative because if we take this x squared minus 4, and if you find the solution, this is also equal to x minus 2 multiplied by x plus 2, right? So finding x minus 2 is equal to 0, x is equal to 2. And then x plus 2 is equal to 0, this is equal to x minus 2. So these are the possible values of x. That's why you have x plus minus 0. But if you're only given, say for example here, you're only given this square root of 4, then the result is only 2. Or if there's a negative sign on the outside, then that will be negative 2. So take note that this only square root of 4 and like this is different. Okay. Okay, so let's have examples, some more examples. Okay, so let's have one square root of 36. So what is this? So this is equal to 6 squared, right? Therefore, this will be 6. Okay, so let's have a second example. Let's say we have the cube root of 125 over 64. So if we rewrite this, this will be 5 cubed over this will be 4 cubed, right? So the result will be 5 over 4. Okay, so another one. Let's say fifth root of negative 32. So the result will be negative 2. So why is that? Because this is also equal to writing negative 2 raised to 5, right? So raised to 5. So this will be negative 2. Okay. So for the last one, let's say we have the sixth root of negative 2 raised to 6. So this will be 2. So why is it 2? Because negative 2 raised to 6 is 64. So we get a positive value here because our exponent is even. So therefore, if we perform sixth root of 64, then we will get 2. Okay, so that's all for this video. Let's proceed with the properties of radicals in the next one. Thank you.